morning, good
Hello,
afternoon, or
everyone.
good evening, depending on where you are in the world, and welcome to today's DevOps.com workshop, brought to you by Techstrong, AWS, and Cong. My name is Cody J. Brown, and I'm the host of Techstrong Learning. We have an exciting workshop ahead, but first I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our workshop or you'd like to follow along later, the recording will be available shortly after we conclude our live session today. We want your questions, we want your feedback, we want this to be interactive. So any thoughts, questions, concerns, we want you to use the workshop chat that's on the right side of your screen. I'll also note that at the conclusion of this webinar, conclusion of this workshop, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So today we'll be covering powering innovation and secure growth at speed and scale. And I'm joined by Claudio Acquaviva, Principal Partner Solutions Engineer at Kong, and Deborah Rocha, Partner Solutions Architect at AWS. We're also joined by support staff from both AWS and Kong to help us out during today's workshop, so thank you everyone for being here. So at this point in time, I'll turn the floor over to our presenters to get us started. Thank you both so much for being here.
Thanks so very much, Cody. Yeah. Hello, everyone. One more time. Welcome. Thanks for joining us for this Kong and AWS workshop. Again, my name is Claudio Acquaviva. I'm a software architect here at Kong. Today, I'm joined by Deborah Rocha from AWS. Deborah, would like to introduce yourself?
Absolutely. Good morning, good afternoon, everyone. My name is Deborah Rocha, and I'm a Partner Solutions Architect at AWS. I've been with Amazon Web Services for about a year and a half now, and I previously worked as a system analyst for the Department of State, and I had many years of experience working for different industries. I'm based out of Seattle, but today I'm joining here from Brazil. So very happy to be here and hope you learn a lot today.
Thanks so very much. So yeah, right now the workshop is based on this the official Kong AWS workshop. You can find the as a matter of fact, there's an open shop, open to anyone. Anyone can try by themselves or using the kong.awsworkshop.io, as you can see in my screen right now, and that we're going through these
Claudio,
workshop
I think
today.
we need to share your screen there.
Oh, I am so sorry. Yeah, that's right. Yeah, we start assuming things, which is not. I hope you can see my screen now.
Yep, now it's working.
Hope
Thank
so.
you.
Yeah, okay, good. So as I was saying, we're going to use this public workshop we wrote a couple of months ago. Again, of course, exploring Kong deployments running on top of AWS services, more precisely Kubernetes, AWS Elastic Kubernetes Service, along with other AWS services like Cognito for OpenID Connect authentication process. So anyone can go to this public website, landing page, Kong AWS workshop.io, and do yourself. Like, we're going to do exactly the same thing we're describing this workshop over here. So, and then the workshop structure, you can see the structure over here. The workshop usually takes 90 minutes, 2 hours to complete. Yeah, maybe longer, depends on the audience, depends on your pace and so on. So a little bit of introduction regarding Kong, very, very important before getting started to provide you some sort of Kong technical introduction. What Kong is, what's the main capabilities, the main values we bring to the table right now. So Kong is an API gateway. So, and as such, is responsible for two main purposes, let's say. Number one is to expose your digital assets. When I say digital assets, I mean any application service you have in your environment, including application servers, including Kubernetes servers, including integration buses, in theory, anyone. And then the Kong gateway will be responsible for exposing these assets to external consumers. That's the main goal of using Kong API gateway. The second one is to leverage and to offload critical, important processes you typically implement in your applications. For instance, authentication. So instead of writing your own code to deal with this not so easy process authentication, but instead of that, leave the API gateway to do it. Not just the authentication, but also other kind of process as critical as including throttling policies, for instance, rate limiting, log processing, caching, and so on and so on and so on. So in summary, again, two main objectives here. Number one, to expose your applications to the external consumers. Number two, to offload critical processes from out of your applications and implementing them in the API gateway. So in this sense, you'll be able to, as we are outlining here, decentralized application services. Your application service can be running anywhere, in theory, anywhere, securing, protecting, exposing, and controlling the exposure with the API gateway, and providing a much easier developer platform in a sense that all developers should go to the API gateway in order to consume the applications, to write their own applications. So that's it. So the thing is, the API gateway also has since you're going to include a new layer, which is the API gateway in our infrastructure, it's very important to have an easy platform in terms of designing your APIs, deploying, taking care of the API lifecycle, and so on and so on. That's the kind of thing we're going to explore today. So of course, this is a workshop, a very controlled deployment. As a matter of fact, the whole workshop is going to be based on a single AWS EKS cluster. It's not really realistic when we come to production-ready environments, but then again, just to provide you an example, a very good example, running API gateway in a Kubernetes cluster. I'm going to show, along the way, I'm going to show some diagrams here, some reference architecture diagrams, in order to provide you some more realistic deployments for real-world scenarios. So what is Kong again? Is an API gateway. So and Kong itself provides lots of capabilities, lots of functionalities, not just the playing the API gateway role, but also provides admins APIs in order to deal with the API gateway, in order to create, to update the policies, to deal with the API lifecycle as well. Kong Manager, that's the GUI, specific GUI for the admins, Kong API Gateway admins, and then you can use the REST admin APIs, if you will. Very useful for CI/CD pipelines, for instance, but also we provide GUIs in order to make our lives a little bit easier in terms of API maintenance and so on. Kong Vitals is responsible for keeping track of the main KPIs of the gateway, including data caching, KPIs, latency time, of course, the number of requests that have been processed by the gateway, and so on. That portal, very, very important component responsible for documentation, API documentation. So all your developers can go to that portal and check the documentation, try the APIs out. We provide some self-services in order to create their own credentials and so on. So that's it. Kong Immunity is being replaced by a new component right now. It's responsible for a machine learning infrastructure responsible for to try to find some threats in terms of API consumption requests processed by the gateway. So then again, we got some descriptions for each one of these components over here, and you can try it out. You can review it later on, if you will. So now I'm going to hand over to Deborah, because now she's going to share some specific artifacts in order for you to get a API, a AWS environment, as well as the Kubernetes cluster provision for you. So yes, Debbie, please go ahead. And then I'm going to share the Cong Enterprise license as well. So everyone, for all attendees, you're going to have an enterprise license for 30 days. So you're free to move on and continue using Cong after the workshop for 30 days, the Cong Enterprise version. So again, Debbie, I'll hand over to you right now. Thank you.
Thank you, Claudio. I will be sharing my screen over here right now. Okay, so for today's workshop, we have a few prerequisites. The first is that we will need an AWS account. We will be providing you a temporary AWS account, and I will be walking you through the setup instructions for that. But these accounts will be available to you until the end of the day today. So you can go through this workshop later if you're unable to follow along. But also, I want to mention that the workshop link, the Kong.aws workshop.io, that is available to you at all times. So you can run the workshop at any time using your own AWS account as well. The second prerequisite that we have here is the Cong Enterprise license that Claudio just mentioned, and that's valid for 30 days. So we definitely encourage you to try Cong Gateway Enterprise with the license. And you can also reach out to us with any questions that you may have, and we'll be happy to guide you through and even get this going on your own AWS account as well. And then the third prerequisite is the command line utilities that we'll be installing. And the last one will also create an Amazon Elastic Kubernetes cluster EKS as well. So we have the workshop link available to you on the chat, and I believe on the screen there as well. So these will be the instructions that we'll be following along today. So we'll get started here under section 2 prerequisite. We have the event engine setup. So if you have the link open, this is Kong.aws workshop.io, and then you select the section 2 prerequisite event engine setup. So with this, we'll walk you through the process of accessing your temporary AWS account. So you can see here, there is a link, the dashboard.eventengine.run. So you can click on that, and it will ask you for event engine hash that I think it's also available there on the chat for you. So all you have to do is basically paste that event hash here, and then accept the terms and login. So you can click here. And here you can see there's 3 options for you. For this workshop, we'll ask you to use the email one-time password option. And here you'll have to enter your email. So it will generate a temporary code. So it can send you your email. And it will generate a temporary 9-digit code that you can use to access the workshop. So I'm just checking here my email. So we'll just enter the code here. And sometimes it takes, a minute or so for you to receive. So, I'll give it a little time, but you just have to enter the code here and then click on signing. So you can see here. So as soon as the authentication goes through, you'll be taken to the event dashboard. All you have to do here is just click on the AWS console button right over here. And then again, click on Open AWS console. So this will take you here to your AWS homepage. You can see here that right now it is taking you to US East 2 Ohio region. So you can see here, and you can also confirm up here. If by any chance you don't have the same region, make sure you change it to US 2 Ohio, just to ensure you don't have any issues during the workshop. So we should always be using the Ohio for this session. So that concludes the AWS account setup that we just went through. So we went through all these steps here. And then now I will change it a little bit. Instead of going to the command line utilities section, I will quickly go over the Kong enterprise license just so we can get all that out of the way. So to get the Kong enterprise license, we will have to create the file. And I apologize, I missed one little step here. So for this workshop, we will be using Cloud9 for the development environment. So you can type here Cloud9 and you can open this, the IDE here. It'll take a second. So here we will be using Cloud9 as the development environment. And all these instructions are based on Amazon Linux 2. So we will be launching an environment on AWS Cloud9 so we can follow along with all the instructions. So when you click on Create Environment, you'll be taken to this screen here. And you can give it a name to your environment. It can be anything of your preference. For this one, I'm just doing Kong workshop, but you can enter anything that makes sense to you there. And you don't need any description. You can click next step. Now here, instead, the only change I'm doing is with the instance type. So instead of using a T2 micro, we'll select the T3 medium. So you can see here. And everything else will keep it as a default. So we're not making any other changes to the environment here. And I'm just changing the instance type just because this will give us a better performance for the workshop. And after that, you can click on next step in create environment. So this will take a minute or two to complete, to create the Cloud9 environment for you. But Cloud9 is a cloud-based IDE. So it will let you run debug code straight from your browser. And also you can quickly share the development environment with your team. You can use that to pair program. And you can also even track each other's input in real time. So it is pretty neat. I definitely recommend you try it out even after this workshop as well. So you can see the environment was created. I'm just going to close this welcome screen just so it's not on the way here. And I'm just expanding here to make it easier for you to see. So now that we have the Cloud9 environment created, now we're going back to the Kong enterprise license. So we can create that on our Cloud9 environment here. So to do that, you will right click here on the Kong workshop. And there's an option, new file. And this file, just make sure you have it at exact that name. So it's license.json. And once you create a file here, you can double click on it. And we'll paste the contents of the license that was shared there with you. So let me copy over here. So we'll paste those contents here. And then you can do file and save to save that. And once that is done, you can close it because we don't need that necessarily open. So you can close it up here. Okay. So now we basically completed 2 steps here. We have the AWS account and we have the Kong enterprise license. Now we're going back to the command line utilities. The first thing we'll do here is to create the home directory so we can save all the binaries. And one thing I want to point out is that on the instructions here, you don't have to manually type all these commands. You can quickly copy using this icon up here. So as you know, you move along through the whole workshop, you can do that. You can just copy the command and then I'm just gonna move here and then paste it here. So that way you're creating a home directory there. And then the first utility that we'll be installing is the EKS Zero. And this is the utility that we'll use to provision the Amazon EKS cluster. So the Amazon EKS cluster is essentially an elastic Kubernetes service from AWS. And that is, for this workshop, we're creating a managed Kubernetes environment. So that's what we'll be doing. So I'll just copy the command here. And we'll add there. Okay. So next, we'll install Cubectl. And this one we'll use just to run any Kubernetes command that we need. We can also paste it here. And we will install Helm. And for this, we will use package managers to install Kong control plane, data plane, Prometheus, CloudWatch. Basically, all the packages that we're using during the workshop will be using Helm to install. So we'll also have to copy this command here. Okay. And for the workshop, we'll also need OpenSSL, JQ, and Siege to generate the certificates and also to parse the output from the command line and generate some load. So we'll install these packages as well. So let's do it here. And we're using Yum for that. And that should be just a second. Okay, it's complete. And then the last thing that we have to do here, we have to ensure that we run the IAM command to create the IAM roles that we require to create the EKS cluster. So this is very important. So please make sure you also have this command here. And now the one last change that we have to do to Cloud9 environment is just in the AWS settings. So if you go up here, there is an icon, a gear icon on the upper right. So you can just click here. We'll have to make this a little smaller so we can see all the options. But then if you scroll down, you'll see AWS settings up here. And you can click on that. And we'll turn the AWS managed temporary credentials off. So you can toggle off over here. And once you do that, you can just close the preferences. And we can make this bigger again. So the only reason we had to turn that off is because Cloud9 normally manages the IAM credentials dynamically. And in this case, for this workshop, we want Cloud9 to use the roles and the credentials that we created. So that's why we had to turn that off. So Now, going back here to the instructions, we completed the command line utility section. And now the very last step for the prerequisite is the Amazon EKS. So we'll have to run the EKS CTL command here to create the EKS cluster. So we'll do that here. And once we run this command, you'll see here, several messages that the cluster is being built. This step will take about 15 to 20 minutes. So while we wait for this to be provisioned, I'll pass it over back to Claudio. And then he will walk us through the reference architecture that we'll use to implement during this workshop. So Claudio, would you like to take it over? I'll stop sharing over here.
So yeah, while we're waiting for the Kubernetes cluster to complete, to get provisioned, yeah, I like to describe a little bit more what Cong is in terms of a little bit more technical deployment. So here's the reference architecture we're going to use for these workshop. Hope you can see it. I hope it's big enough for you. So before talking about it, let me share one more time the enterprise license we're going to be using for this workshop. The Kong enterprise license, valid for 30 days. Please check the chat again. As Deborah said before, you are supposed to create a license.json file, including these content in there. And then you're going to use it later on when you're deploying the Cong API gateway in the Kubernetes cluster. So again, here's the reference architecture we're going to be using for this workshop. So a couple of very, very important comments, first of all. So as you can see, the Cong gateway is running inside the Kubernetes cluster. But then, as you can see, there are two namespaces. And why is that? Because first of all, the gateway is divided, it's being split up into main components. The first one, the control plane up there, running namespace number 1. The control plane, that's the components that's the component of the API gateway responsible for admin tasks. So you, as an admin, you go to the control plane, and then you start creating APIs, applying policies for these APIs, updating the policies, deleting the policy, the APIs, and so on and so on. Any admin tasks should be done by the admins using the control plane. As you can see, the control plane uses a PostgreSQL database as its repository. So we are not doing right now because in a workshop, this is a workshop, the Postgres database is also running inside the same, will be also running inside the same Kubernetes cluster. For production-ready environments, we highly recommend to use the Postgres database, to deploy the Postgres database externally. And then that will be a great idea to leverage AWS RDS for PostgreSQL to take advantage of the critical capabilities provided by the service. So then again, we highly recommend to run PostgreSQL outside the Kubernetes cluster for production-ready environments. Again, just for the purpose of the workshop, to get an easier deployment, we're going to run Postgres inside the Kubernetes cluster. And then we got the second component, which is the data plane. The data plane, on the other hand, is responsible for the API consumption. So if you want to create a new API, again, you should go to the control plane. As a matter of fact, if you go to the control plane and send a request to consume an API, you're going to get an error. The control plane is going to say, hey, I'm a control plane. I'm not supposed to handle any API consumption request. You should go to the data plane in order to consume the API. And the same thing, the other way around is still true. If you go to the data plane and try to create a new API, the data plane is going to say, hey, you should go to the control plane because I'm a data plane. I am not supposed to handle any admin task request. So again, data plane is here to expose the APIs you have created in the control plane. And that's exactly what it's doing in this diagram. So, but then again, there's a very important nuance here. As you can see, there are multiple instances of the data plane. And why is that? Because we want our data plane to go elastic, in a sense that we should support the throughput you're going to have along the way. Something like the more traffic you have, the more instances of data plane you're going to have. And then if you have a not so heavy throughput traffic right now, maybe that would be a nice idea to terminate some instances of your data plane. So in other words, we're going to take advantage of specific Kubernetes capability, which is HPA, for those familiar with the Kubernetes horizontal pod autoscaler. So Kubernetes, more precisely HPA, will be taking care of these elasticity capability for our data plane. So again, the data plane, you're going to have multiple instances of the data plane along the way, based on the throughput you experiencing at a given moment. That's a very, very important requirement, technical requirement to address. And then again, the combination of Kubernetes and Cong data plane, it's a perfect fit to address this kind of requirement. So the data plane, as I said previously, the data plane is responsible for two main purposes. Number one, to expose the services you're going to have sitting behind the gateway, behind the data plane, to be more precise. But then again, the second purpose of the data plane is to offload critical processing you typically have in your upstream services. Examples. Authentication. So this time, the gateway, more precisely data plane, will be responsible for authenticating the consumers sending requests to the API gateway. And then in this sense, the data plane will be responsible for integrating Cognito in order to implement the OpenID Connect based authentication process. Or maybe you're going to use classic Microsoft Active Directory. And then that will be the case to use the LDAP plugin to integrate with the Microsoft Active Directory infrastructure provided by AWS, of course. So all these integration points, just mentioned two of them, Cognito and LDAP, this is possible because we provide extensive list of extensions. We call these extensions plugins. Each one of these plugins is responsible for a very specific capability. Again, OpenID Connect is responsible for the OpenID Connect authentication process. Therefore, the Cognito integration. The same thing applies for the LDAP plugin. The same thing applies for Prometheus plugin. So in this time, you're going to integrate with Amazon. It's not designed over here, but you can integrate with Amazon Managed Prometheus, Amazon Managed Grafana, Service for Grafana, and so on. So you integrate StatsD, advanced plugin, for instance, you can integrate with CloudWatch. Proxy caching plugin, you can integrate with Elastic Cache for Redis in order to implement Elastic Cache. We're going to try more precisely the rate limiting plugin during the workshop using the Redis, not Elastic Cache for Redis. To have a little bit easier deployment for Redis, we're going to deploy Redis inside our Kubernetes cluster. And then we're going to use the rate limiting plugin to integrate it with this Redis infrastructure. Other plugins, very, very important, TCP logging plugin, TCP log plugin, very, very important to get this elastic open search service integration in place. So this time the data plane is going to externalize all the requests that have been processed by the data plane to external infrastructure, in our case, OpenSearch service. And then you can, again, start using the OpenSearch service capabilities in order to build your dashboards, your alarms and reports, and so on and so on. So kind of this diagram over here, just to provide you some sort of, integration perspective, not just with the AWS platform, which is Kubernetes, but also with AWS services as well. So one final comment here is that Again, for this workshop, we were using Kubernetes as our platform, but then again, Kong supports any other AWS platform, including AWS ECS, including EC2s with auto-scaling group, and so on and so on and so on. Of course, we are focusing on right now, today, we're focusing on Kubernetes, but then again, keep in mind, we can have the gateway deployment using multiple platforms at the same time. Meaning that it's totally fine to have your control plane running, for instance, in ECS and the data plane running in Kubernetes. It's totally fine. It's up to the architects to decide to come up with this kind of decision. Like which platform we're going to use for these or that component of the API gateway. This kind of flexibility we're bringing to the table right now. Very, very important flexibility. If you're considering workload transfers, for instance, you got some workloads running on premise, or maybe you got some workloads running on EC2, and then you want to decide to move these workloads to a container-based infrastructure, again, ECS, Kubernetes, that's kind of, freedom we want to support. So you're going to make your technical decisions, and then we are going to support your decisions, regardless what they are in terms of technology, in terms of platforms, and so on. I think, let me share my class. It's still getting created, getting deployed. Yeah. So I just wanted to take some time to describe other reference architectures. For instance, this one, they're all based in AWS, again, of course. This one, right now, as I said before, control plane can be running in another platform. This time, just because I'm using EC2 VM, the control plane is running as a Docker container. Again, I got a PostgreSQL behind the control plane. Only behind the control plane, the data planes don't have any database. They are totally DB-less, lightweight, easy deployment, fast and easy deployment for the data plane. No dependencies in this sense. And then the data plane, we have I got two data planes right now. The first data plane is running in another VM as a Docker container as well. And the second one, just like my first one, is running Kubernetes. And then Kubernetes seems to be a much more interesting platform to use because, again, to take advantage of these standardized capabilities. HPA is just one of them. I can talking about Knative, certification manager, and so on and so on and so on. These are the deployment over here. That's the one we're going to explore this time. Now I got the Prometheus and Grafana in my diagram here. So a little bit more updated. And then finally, last but not least, that's my favorite one, I should say. So 3 Kubernetes clusters this time. The first one running control plane. And then the control plane, as expected, receiving requests from the admins using REST admin APIs or using the GUI. And the control plane is also receiving requests coming from your CI/CD pipelines, provisioning processes, using AWS tooling, for instance, AWS code commit, code pipeline, code build, code deploy. You can use these guys to send provisioning requests, API creation requests, or policy creation requests to the control plane. And then the control plane will be responsible, as usual, to publish the APIs and policies to all data planes you got at a given moment, a given time. So for instance, the diagram, I got 2 data planes, the first one running EKS Anywhere to support your on-premise workloads. So let's say you have some application running on-premise, that will be reasonable to have a data plane specific for these workloads. That's the role this EKS Anywhere is playing right now. And the second data plane is doing exactly the same thing, but for this time is running as a traditional EKS cluster running in the cloud, region 1 to support, to protect specific workloads you got up there. Again, last but not least, the two data planes, they're sharing exactly the same collection of AWS services I described before. Cognito, Prometheus, OpenSearch, Redis, and so on and so on and so on. So that will be it. Let me see, my Kubernetes is still being created. So not sure if the audience, you should have some questions from the audience. Nope. So yeah, maybe you should take a break right now. The cluster should be ready in a moment. Yeah, mine. Let me share one more time my screen, Deborah. Mine is ready.
Did yours finish running?
Yeah,
I think
it is
mine
ready.
is still running.
Yeah. Can you see mine?
Let me see. Yep, I can see your screen. Mm-hmm.
Yeah, and then just the regular pods you got right after deploying a Kubernetes cluster, EKS Kubernetes cluster. So the regular services you got.
Yep, mine is running a little bit slower, I think, because it's not done yet.
It's a fresh Kubernetes cluster. So we're going to be playing with this Kubernetes cluster with our we're going to define namespaces, two namespaces, one for the control plane, the second for the data plane, and so on and so on and so on. So that would be it.
Mine just got done here as well.
Okay, good.
Okay, so I'll be sharing my screen again. Let me here. So if you can let me know when you can see it. I hope everybody's
Not
cluster.
yet.
Not yet?
Not yet.
Let's see, I think. Okay, I think it's showing now. You can see it now, right?
Yes.
Okay,
yes.
Perfect. So you can see, my cluster was also created. And going back here to the instructions for anybody that joined a little bit late, just so you know where we are right now. We're still here finishing, we just created the EKS cluster. So we're here on the prerequisites, Amazon EKS. We run this command. It took a few minutes. So you should see some output similar to that. And then we can run this command here to verify, like Claudio just did, just to verify everything is up and running. So you can confirm here all the pods are running. And then one important step here is that we need to export the environment variables because these will be used in other sections of the workshop. So if you miss running this step over here, this will prevent you from following along. So please make sure that that you run this command here to ensure that we have that there. And then once we have that, we are basically finished with all the prerequisite section of this workshop. So we are all done with section 2. I don't know if anyone has any questions up at this point, or if you're ready to move to the Cong enterprise setup. But if you do, I'm gonna just check here really quick to see if there's any comments. Okay, yep. So in case there's any questions, please feel free to post there on the chat as well. So now that we finished with the Eks cluster, we'll move into the Kong Enterprise Setup section. And as Claudio mentioned today, we will provision both the control plane and the data plane in different namespace, but they will all be in the same cluster. So in order to follow along, now we'll move into the section 3, and you can go here to the MTLS setup part to follow the instructions. And then here, we'll create a certificate key pair that is required for node-to-node communication. So we'll create that certificate key. So we'll just copy this here. And then we'll also need to create a namespace for both the control plane and the data plane. So please make sure you're copying both of them, both of the commands. Otherwise, that may prevent you also from following along. So just make sure we have both of them there. And then once we have that, we're going to create or mount the certificates as Kubernetes secrets. So that can be used in subsequent steps also for MTLS. And then we also will mount the license that we created as a Kubernetes secret. So when we do the Helm installs, it can use that. So the first step is to create the secret. And then we'll mount the license as Kubernetes secret. And we have to do that also for control plane and for data plane. So just make sure you have both of them. Great. So, so with that, we finish this section, and we'll move into the Cong control plane instructions over here. And the first thing we'll have to do is we'll have to install Cong control plane on the EKS cluster that we created, and also Cong namespace. And we'll get started by installing Helm charts first. So we'll go. And for the Helm install, what that is doing is that is installing the Cong control plane and some other key values that we're passing in the Helm install, like the MTLS keys, the license keys that we have created in the previous steps. We're also creating the Postgres SQL. So all of that is being done with that. And we're also exposing the admin API as a load balancer as well. So basically the Helm install will take a few minutes to run, a couple minutes to run, but that will create the admin API that will expose the load balancer for the control plane. So after we finish installing Helm charts, we'll install the control plane. So you can see here is installing all the Postgres SQL. And yeah, so once that is completed, we can validate that installation to make sure everything is running as expected. So you can also paste this command here. we're still, it takes a minute or two for that to happen. So we'll just give it an extra minute here to make sure it's all good. So just retry the command. It's still not done. So we'll just, it looks like I got an error, but we'll wait another minute to see here. Crash loop back off. So we'll see. We need to. Are you able to run that command just fine there, Claudio?
Oh yes. Oh yes. Yeah. I got the control plane and data plane already deployed.
Okay. Yeah, so I think it just took a minute because now everything is running. We can confirm
here.
here.
The control plane takes a little longer because going to bring all the images and deploying the Postgres database and you're going to bootstrap database with a couple of tables in there and so on. So it takes a little longer.
Okay.
Not that long.
Yeah.
Not that long, but yeah.
Awesome. Okay, so now that we install the data plane, sorry, the control plane, we'll expose the environment variables for the load balancer that was created. So we can run the command here, this echo command. And we can also do a curl on the admin API on port 8001. And when we do that, let me confirm I didn't finish doing the echo. So we can see here the URL. And if we do a curl over here, you should see the version. So it should show for you the 2.6.00 Enterprise Edition. So you should see that. Now, the next step that we'll go through, we will configure the UI. So you can see the UI running, and then you can visualize the services that are set up. So in order to configure the Cong Manager service, we have to patch to use the environment variables that we created before, and to pass the control plane load balancer that is saved as an environment variable. So we can do that here. We can run this command first to configure. So it is patched, and we can also use this. Sorry. Okay. And then we can also copy the login to Cong Manager up here. And then just run this last command here so we can actually see the URL. So when you get to the URL, you can copy this over. And we can open on another browser here, another tab. So now you're able to see Cong Manager. One important thing here is if you're having any issues to load and to view the Cong Manager dashboard, make sure you're disconnected from your VPN, because that may be blocking you from seeing the dashboard. So if you disconnect from the VPN and then try to reload, you should be all good. So just make sure you follow that. So with that, we have completed the control plane section. And now we'll move into the Kong data plane. So we'll install that. So the first thing we'll do is we're gonna create the secrets for the data plane nodes so that it can communicate with control plane. So we can create the Kubernetes secrets here. Let me make sure I copy it right. So we'll paste it again to create the secrets. And then we'll install the data plane itself over here. And we can also, once it does take, it may take a couple seconds to a minute here to load, but we can make sure the installation is correct, just like we did for control plane. So we can paste this here. And it's already, we already have it available and it's running. So we should be all good. And then we can run the curl here. So we can make sure you can see here all the IP, you can see the config hash, the host name. So all the important information is being brought over. And now after that, one important thing is that the data plane proxy, that will be the next step here. And the data plane proxy will be using that as a consumer of the API that will be hitting. So you can export the data plane load balancer as an environment variable. So we can use that in the next steps. So for here, we can do the echo command as well. And you can see the entire output that, and then we can also do the curl to the load balancer. And then, sorry, I forgot to do the echo again. So once we can see here the URL, and when we do curl, we should get a message that no route matched with those values. And this is not an error message. This is the expected in a valid message because we did not specify any routes just yet. This will be added in the next steps. So you can even, if you copy the URL here, you can, you'll get the same message that no route matched with those values. So this is the expected message that you should be seeing here. So with that, we also finished the Cong data plane section. And the next portion that we'll be covering here is setting up the elasticity. So that will be what Claudia was talking before, the horizontal pod autoscaler, or the HPA. So if you run this command here, you can see the deployment before scaling out. So you can see here that at this point, we only have that one pod taking traffic. We can actually also run this command here too, so you can actually see the pod that is running. So right now we only have that one pod, but as the consumers of the API, you know, if that increases, the traffic increases, then the data plane can auto-scale, you know, horizontally and add more pod replicas to your cluster. So, so for that, you know, in this case, you can also, like, you will show here how you can manually scale out if you want. So it's, you know, it's creating 3 replicas, and you can easily manually do that. But for this workshop and also in the real world, like normally, you know, you want that process to be automated, so you don't have to actually go there and have to manually do those steps. So that's why we use HPA. And then in order to use HPA, we first will have to install metric server in the Kubernetes cluster. So we can go over here, and that's what we have to install first in order to be able to install the HPA. And then, oops, sorry, another screen here. And then we can also test that to ensure that is working. So you can see it's running. The metric server takes a second, so it should be up and running in a minute or so. But that would be the first step to be able to use HPA. And once it is running, sorry, once it is in a running state, then what we can do is we can update. Let's just finish, wait for this to run. Let me run this command again just to make sure. Okay, now it's all up and running. So we have metric server. So we will turn on HPA. And you can see here, there's some set of instructions here, but this is just actually a demo of some of the values that you could have here. But if you're actually copying the command, make sure you're selecting this other one down here. So we can copy these and paste here. Great, so that's installed. So what that is doing, you know, you can kind of define, you know, the min, max number of replicas you want. You can define how the scaling should be working. Like, you know, you can define all the values on how HPA should be working. So in this case here, it's showing that once the average CPU utilization is over 15%, then it will launch more replicas. So that's how you would, you know, create the settings for the HPA. Now we can check the HPA that we just set up. And you can see here right now we only have one running. But then if we run this other command, then we can see the HPA status as well. So here you can see the 15% that I was just talking about. We have set up a min number of pods to 1, a max to 5. And right now you see here 0. But as we generate load during the workshop, you'll see that auto-scale and that number would change. So with that, we are done with the elasticity portion of the workshop. The next step is setting up the observability. And this is a very critical step in running Kong and AWS. It's a way for us to have a control over the telemetry information that you're collecting. But then today, in respect of time and to make sure we're able to cover the most important parts of the workshop, We will not be doing that together here, but you can do that. We'll take 15 minutes. Claudio, does that sound good? 15 minutes
Yeah,
for
absolutely.
everybody?
Yeah,
Okay.
15-minute break, and then when we come back, I'm going to to review everything we've done so far, and that's it. So
Okay, perfect.
15 minutes,
So we'll
15
give you
minute break.
15
Yeah.
minutes then for you to go over the observability section on your own. If you have any questions, you're stuck, there's anything you want to ask us, please make sure you post there on the chat, and we'll have someone get back with you. So with that, I will stop sharing here, and we'll be right back.
Right now, let's slow down a little bit, and let's review what we had done so far. So let me share it one more time my screen again. Yeah, hope you can see my screen now. So here's my environment. I have two windows in there just because I'm going to do multiple things at the same time. So here's my Kubernetes cluster. It's deployed, and then I just wanted to review the pods. We are supposed to get something similar to this at this point. So let's review these pods a little bit. Deployment as well. If you can check the deployments, Cubectl, get deployments. So all the deployments, all the services, including the load balancers, for both Cong and Grafana, and proxy, of course, the data plane proxy. So we are supposed to have some load balancers also deployed. So again, let's review the pods. So again, namespace Amazon CloudWatch, the pods we are going to use to integrate the CloudWatch. We're going to use FlintD this time. To get it, FlintD will be sitting in the middle, the data plane and the CloudWatch infrastructure. Kong DP and Cong namespaces as originally planned. So the Kong namespace, that's where the control plane is. As you can see, there's a Postgres pod right inside of it. As I said before, we're doing this just because of this workshop, because we're running a workshop. Again, we highly recommend to run Postgres outside the Kubernetes cluster. And then we got a second pod, which is init migration pod. As you can see, it's status completed. This runs only once. Its responsibility is to bootstrap the Postgres database, creating multiple tables. So Cong, the control plane, is going to use these tables as its repository to store all the API, all the metadata repository. And then you got the third pod, which is the actual control plane connected to the Postgres database, using the Postgres database as the repository. And then in the second namespace, you got ConDP namespace, you got data plane pod up and running. That's the namespace you can play with the HPA capability in order to get more or less pods running at the same time in order to support a heavy throughput you might have in a given moment. I'm going to play with these DP namespace a little bit later, just to exercise the rate limiting capability. It's going to be fun. You're going to see that. I'm going to create new replicas for these deployment. Replica set, I'm going to set the replica set to 3, just to get 3 pods up and running for my data plane. I'm going to do it in a moment. And then kubesystem, that's the regular namespace for Kubernetes, and Prometheus namespace, where my Prometheus operator, Prometheus operator, Grafana deployments are. So as a matter of fact, here's my Grafana already deployed. When I deployed it, the Grafana, I got the Elastic Load Balancer specifically for it. I'm just using it, and that's it. That's my second Elastic Load Balancer. That's specific for the control plane. So what you're seeing right now, this is the Kubernetes perspective of the deployment, and then we're going to see the Cong control plane going to zoom in the control plane. So right now, what you're seeing is the control plane admin GUI. That's the GUI I mentioned before. It's used by the admins to create APIs, policies, and so on and so on. So inside the Cong Manager admin GUI, you can see this main dashboard over here. Of course, I'm not injecting any requests into the data plane. That's why I'm not seeing anything here. So once I'm going to start injecting or sending requests to the data plane, and then we are going to see some activities in here. And then you can see down here a specific notion. We call this workspace. That's the way to define groups of APIs, multiple admins, defining multiple APIs at the same time. That will be a good idea to get these admins working in separate collections of APIs. That's why we got this workspaces capability in order to create collections of APIs. Therefore, each admin will be responsible for his own workspace. So this workspace capability is usually use the Teams capability along with workspaces capability. So Teams is another capability. That's the component used to invite new admins, to define rules, therefore grant and revoke permissions to these admins to create new APIs or maybe apply policies or define policies and so on. So again, usually in a real world scenario, you invite multiple admins to be part of the admin team, and then each one of these admins will be responsible for a specific workspace, or maybe more than one. So yeah, usually workspaces and teams, they go together. And then usually we got multiple workspaces. You can create new workspaces over here. Let's use our default workspace. And then you can see over here the fundamental constructs. So the most important object from the gateway, from the control plane perspective, is the Cong service. I know the service term is being overused, overloaded. Everybody uses service to refer to this and that and this. I'm talking about Cong service. So what is a Cong service? A Cong service is an abstraction of an endpoint you are exposing. One of your applications is exposing this time. So again, you're going to have multiple applications. Each one of these applications are supposed to expose some endpoints. You're going to create Cong services based on these endpoints. I'm going to do this in a moment. Just describing the main notions of the control plane, the Cong control plane right now. So again, Cong service is a way to abstract one endpoint provided exposed by your applications, your existing applications. On top of this service, you're going to create routes. A route is a way to expose a previous Cong service created to the outside world. So you, as an external consumer, you're going to send requests to the data plane. More precisely, you're going to send requests using these routes the admins previously created. And then the route, again, is going to expose the specific service, which is, again, just an abstraction of your applications endpoint. So I'm going to do this not using the admin because we are using Kubernetes. So that will be the case to explore the specific Kubernetes capability provided by the control plane, which is the CRDs. So for those familiar with Kubernetes, the way of doing things in Kubernetes is declaring things, just like we're doing with the other components like Prometheus and Grafana and so on. So this time we'd like to create our routes and services, Cong services and Cong routes. Of course, you can do it. You can do it using the admin GUI, but then again, because again we're using Kubernetes, that would be the case to use our CRDs to create services and routes. I'm going to do it in a moment. One last thing before we move on, I'd like to talk a little bit about these plugins. Again, plugins are extensions of the gateway. Each one of these plugins is responsible for a specific processing. I have already configured two of them, Prometheus and FileLog Prometheus. That's the plugin I'm using to connect with my Prometheus infrastructure deployed in a different namespace. FileLog, that's the plugin I'm using to integrate with the FluentD, therefore CloudWatch. We're going to configure other plugins later on, rate limiting plugin, API key plugin, and so on. So right now, just reviewing what we have done so far. So I think that's it. So first of all, let's move on. Let's take our workshop guide over here. Before defining routes and services and so on, we need to have some applications to expose. So let's deploy two very, very basic applications. One application is called the Echo service, just a Echo system. Like, you're going to send a request to it. They're going to reply with exactly the same request, like, all the information we got in these requests, like, all the headers, the payloads, and so on. There's a very basic application. So let's deploy it in our Kubernetes system. And then we are supposed to get more pods. So yeah, creating these two pods over here, new pods. This is a public application. Anyone can use it. Like, nothing really related to Kong or AWS. Again, it's a very well-known application. Anyone can use it. And then we're going to deploy another application, HTTP bin application. Is connected to the public HTTP bin service. Again, just to get something to expose to the outside world. So again, we have four new pods, two for the Echo service and two for the HTTP bin service. And that's it. If you check the service, they've been deployed at cluster IP, meaning that they are closed. Nobody from the outside, nobody's supposed to consume them. So we need to have something responsible for exposing these services, this Kubernetes service, to the outside world. This something is the data plane. So we're going to use the data plane to expose this service to the outside world. And then, so just checking the deployments over here, nothing really special. And then now the most critical, I would say, the surgical part of our deployment. So this time we're going to declare ingresses. Ingress, first of all, is nothing really related to Cong. It's an abstraction defined by Kubernetes. So if you go to Kubernetes official documentation, you're going to see the ingress spec, the ingress definition there. So in this sense, since you're running Kubernetes, this time we're not reinventing the wheel. We're just following the standard Kubernetes specification in order to expose the services we got internally in our cluster. So, and then, as you can see here, this is a very first basic ingress declaration. So what we're doing right now, this is the most critical step. So what we're doing right now, we're defining an ingress. This is not, again, this is not related to Kong. This is related to Kubernetes. Kubernetes defines what an ingress is. We're just following the Kubernetes standard this time. We're saying that, the guy responsible for taking care of this ingress definition is going to be the Cong control plane. As a matter of fact, another thing I like to show you, not just the pods and the service, but if you check the CRDs, you're going to see some new CRDs in your Kubernetes clusters. So for instance, Kong consumer, Kong ingresses, Kong plugins, Kong cluster plugins, and so on. These are brand new CRDs you got after deploying the control plane. So that's the way we support the Kubernetes CRD standard, defining new CRD classes. As a matter of fact, the ingress is not exactly as something, as I said before, not exactly something we define. It's built in your Kubernetes. Any Kubernetes cluster should provide your ingress class, ingress CRD class for you. Again, we're just following the standard over here. So I'm saying that, Kong will be responsible for taking care of this ingress definition for us. And then that's the most important part of your ingress definition. You're going to define paths /foo, just a path, just a name, could be anything. But then this path is related to this Kubernetes service. This is a Kubernetes service, HTTP bin port 80. So the ingress, again, one more time, the ingress /foo is related to the Kubernetes service HTTP bin port running exposed in port 80. That's exactly what we got here. If you check the service one more time, you're going to see the HTTP bin service listening to port 80. So we're referring to this guy over here. That's the ingress is doing. Of course, we are submitting this ingress declaration to Kong control plane, and then the Kong control plane is going to push this ingress declaration to the data plane. But this time, because it's a data plane, it's going to be a collection of Kong routes and Kong service. Let's do it. You're going to see a better perspective after running this command over here, this declaration, submitting this declaration over here. So again, let's clean this up. And then I'm just submitting this. Oops. That is bad. There is no extensions. This is not supposed to, maybe I should use the, maybe some conflict with the Kubernetes version.
Claudio, you can remove beta 1 from the API version in that manifest and just have extensions /v1. That should work for you.
Oh, yeah. Yeah, that will be something like, for the newer Kubernetes version. Am I right?
Right.
See extensions v1 or just v1?
Claudio, the version will be like a networking.k8s.io, then a v1. And also, I think in this version they have a little bit changed, like the path should be with the path type as a prefix, and also the port number and the port name.
Yeah, different.
Yeah, they have some different small changes.
I know, but for Kubernetes version 1. We are running Kubernetes 121. You're supposed to support these Ingress declarations as well. So yeah, just a second, please. Yeah, I should say, like, instead of, struggling with these declarations over here, let's do exactly the same thing using the GUI. So instead of using, we are supposed to create these Ingress using these declarations. So something like, something related to the Kubernetes version and the declaration using right now. So instead of struggling all this, you can move on using the GUI. So for instance, you can define a new service, service one, and then you can refer to endpoint. For instance, I'm using the external endpoint, HTTP bin endpoint, not exactly running my Kubernetes cluster. So kind of, again, I've just defined a service one, Kong service one, based on these endpoint provided by your, just pretending is one of your applications. And then on top of these service, I'm going to define routes. And then I'm going to, for this route, I'm going to define a path like /foo, for instance. That's it. So you are supposed to see a new route in place. If you click on this route, you can see the configuration again. You can edit the configuration, if you will, changing the configuration. And then the same thing for the service. See the service, and then you can see the route built on top of it. And then if you go to your data plane, the control, you've done this again, you submitted, you created the service, your control plane, and then the control plane is supposed to publish this definition to the data plane. So if you go to the data plane, you are supposed to see the route being exposed. So if you go to our data plane, my data plane is over here. So here's the elastic load balancer of my data plane. If you use it, consume it using HTTP, for instance. Oops, not available. So it's saying a no route matched, meaning that, I have reached the data plane, but then again, I'm not specifying any route. So again, if I send another request this time, specifying the full route, I'm supposed to hit the HTTP bin. So then you can use the get verb, if you will. So get is here. So what's happening here? So you're sending a request to the data plane. So you created the service and the route in your control plane. The control plane published the service and route to the data plane exposing to the external consumer. I am just consuming the route you created before. And then the route is routing my request to the external service, which is HTTP bin service. So far so good. If you check the Kong admin GUI again, you're gonna see the route and so on and so forth. So kind of the data plane is just playing the proxy role right now. And then we just wanted to, it's good, it's exposing the external service, but not really controlling the exposure. That's why we start defining policies for these route or service. So let's say we want to control this full route consumption. So right now, as you can see, I can see the number of requests that have been submitted, have been sent to the data plane, and so on. And then I'm going to apply plugins to it in order to define policies to control this exposure. If you click on this add new plugin page button, you're going to see the extensive list of plugins we provide, including authentication-based plugins. So you can define all sort of authentication mechanisms for for your route. So, for instance, if you define a base authentication, you're going to require user ID and password pair for your consumers in order to consume this route over here. Then base authentication, API keys, LDAP authentication, mutual TLS, Open Connect. That's the one you're going to use to integrate the Cognito, and so on. And then we provide plugins related to security, in order to implement CORS policies, for instance, IP restrictions, OPA policy, that's based on the OPA Open Policy Agent engine to define access control policies, traffic control to define canary releases, mockings, proxy caching, rate limiting. We're going to use rate limiting to define a very basic rate limiting policy, and so on. Serverless, very, very important to integrate and abstract any AWS Lambda functions you might have in your environment. So in this sense, the consumers, they are going to send requests to the data plane. Data plane is going to route the request to the AWS Lambda you got behind it. Last but not least, the analytics monitoring plugins, related plugins to support Datadog, Prometheus, Zipkins, transformations to support transformation inside the API gateway layer. So this time you can, for instance, transform the request before routing the request to the upstream service, or transform the response coming back from the upstream before getting back to the consumers. You can translate REST request into Kafka event and post it to existing event streaming processing, and so on. And all these logging plugins also available. For instance, StatsD, that's the one we can also use to integrate the CloudWatch. TCP log, that's the one we typically use to integrate the OpenSearch, and so on. So to get it started, very, very basic policy, I'm going to use the rate limiting policy. And then there's specific configuration for the policy. So one specific one is just, 3, meaning that I'm going to allow these, I'm going to control the exposure with this policy, meaning that this policy is supposed to be consumed only 3 times a given minute. So if you create this policy, again, you see my route, this time with the policy enabled. And the policy is a plugin, the rate limiting plugin. You can review the configuration for your plugin, and so on. And then if you go back to our data plane, you are supposed to get something. Let me see. You are supposed to get a 429 error code, meaning that eventually, meaning that we have reached the rate limiting policy. Eventually, we reached the rate limiting policy, meaning that we're trying to send more requests than the plugin have defined. So we have reached the rate limiting policy. If you go back to, again, send it again. Of course, right now we're in a different minute. That's why the counter is refreshed, and then getting another 429. So what happens if you want to change the policy? Let's say 3 times. I don't like 3 times. Just change the policy. This time, let's change it to 5 or 10, for instance. Just change the policy for my route consumption. Then you can review it, if you will. Minutes, 10 times a minute. And then if you go back to the data plane one more time, let's run a loop right now, just to oops. So the route is foo get. If you start a loop, you're going to see, like, eventually, let's sleep a little bit. So anyway, like, it just, yeah. Let's sleep. And just a matter to wait for another minute, and then we'll be able to consume the route again, of course, and then we're going to reach the rate limiting policy one more time. So that's it. Unfortunately, we are facing some. Yeah, there we go. Like, we just got another minute. We just got into another minute. That's why we're capable right now. We're able to consume the route. But eventually, we're going to hit the rate limiting policy one more time. We're going to get the 429 one more time. There you go. So unfortunately, we are having some version mismatch this time with this Ingress declaration. And but again, like, the purpose of this is to do exactly the same thing, not using the GUI, but using the declarations, the Ingress declaration. So the Ingress, this Ingress is supposed to work on a previous version of the Kubernetes, and that's it. So Deborah, I think that would be the case, like, to give some time for attendees. We're it's almost 2 hours workshop right now. So
you want to give them a little time to catch up?
yeah, especially because we got these Ingress declaration mismatch, version mismatch.
Sure. Yeah.
And yeah.
Okay. So
because all the declarations we got in workshop, they're based on the specific Kubernetes version. So yeah.
Yep. Okay.
So yeah, not sure if the audience has got some questions related to it, related to workshop, the deployments. Okay, so yeah, I think that that would be the case, like, for to give our some time to our attendees, like, to make sure they can follow the instructions. But then again, we should update these either ways, like, to update this Ingress declaration or to use another Kubernetes version. So
hey Claudio, if you want, I can ping you a specific declaration that is working with 1.22 version. I think we can just demonstrate that. if that works.
Yeah, okay, good. So let me destroy this route and service because, you know, again, they're based on the same /foo. Sharing my screen. Let's share my screen one more time.
Yeah, and Greg has the updated version.
Oh, thank you, Greg. Yeah.
Yeah.
Yeah, let me go back to delete the service. Yeah, that's the one, right?
Claudio, I sent it to you on Slack as well, which would probably be easier to copy it from there.
Yeah, it's like the API version is a little bit changed, and also the way to write the port and the service name in the service.
Yeah.
Yeah, they change it in another way.
Yeah. Yeah. Now I got a new declaration. And I'm going back to the, yeah. So again, here's the new declaration. Now we got it. So yeah, the Ingress declaration this time is a little bit different because, you know, we're running a different Kubernetes version. It's some kind of, you know, path type is being changed, like implementation specific. And then we got to define the port in a different way. But then again, you know, the point is we got the Ingress defined. If you go back to our Cong manager again, you are supposed to see the services, as a matter of fact, the Cong services and the Cong routes. Because again, if you go back to Ingress, we're defining two ingresses, one for the HTTP and the other for the echo service. That's why we got two services and two routes defined in the control plane. And then if we try to consume it, /foo, as specified over here. Let's clean this up. And then you're supposed to consume it. So another declaration over here for this time for the other application, the HTTP being application, you are supposed to have a different Ingress declaration over here because of the Kubernetes version running, and so on. And that's the way we do to enable the plugin to our service. Again, instead of using Cong Manager as I did before, we're going to use using the CRDs. You're going to use it. You're going to do it using the CRDs. So now we're going to use the response transformer plugin in order to transform the response before getting back to the consumer. So if you submitted this declaration again, yeah, and then you can check the ingresses. And you can check the Cong plugins. Cong plugins is there. You can even run describe Cong plugin in order to check the header configuration. The plugin configuration. Again, is the configuration we used for the plugin. And then what happens is, let's clean this up again. What happens is if you try to consume it, oh yeah, we got to apply one step more. We got to apply the plugin as a notation for your ingress. Another step. And then if you try to consume it, this time we are supposed to have a new header injected inside our response. So here's the new header. So something like Cong routed your request to the upstream service, which is HTTP bin, and then injected the new header before getting back to the consumer. That's why we're seeing the demo header, the new demo up here. That's the kind of thing you can do using the request transformer plugin. So yeah, of course, the plugin has been applied for just the first ingress. So of course, if you try to consume a second route we got, which is bar, you're not supposed to see the new header. Oh, I'm sorry, the bus. I'm sorry, yeah, the bus. You're not supposed to see the new header injected inside of it, because again, the plugin has been applied only for the first ingress. So yeah, and then we got other plugins to enable, for instance, the API key plugin in order to control not just the number of requests you're going to support in a given moment, using the rate limiting, of course, but this time you're going to request a credential from your consumer. So this time we're going to apply another Cong plugin. This time is the key auth plugin. That's the API key plugin. If you consume it, if you apply it, and check the ingress, we got to, again, we got to enable the two plugins. Now we patched the ingress again, this time with the new plugin we created before. So here's the plugin we created. We're applying the plugin to the ingress. This time, if you try to consume the ingress, you're going to get a specific error, no API key found in request. So a different policy this time, not a rate limiting, but API key policy in place. And then in order to consume it, you have to create a Cong consumer. Cong consumer is a way to define a consumer. And then this consumer is going to have a API key. And then you should be able to consume these ingress this time. So here's a consumer. I'm naming it Harry. It's a Cong consumer. Now I'm defining a secret for this consumer. First of all, define a secret. And then now I am going to add this credential, this secret, to the consumer I previously created. So 3 steps. I create the consumer, I create the secret, I create a consumer over here, I create a secret, and then I added the secret to my consumer. The secret is just a little my super secret key. That's my credential over here. And then now I should be able to consume the API, injecting the API key. So here's my my new request. clean this up, and then I'm supposed to consume this API. Of course, if I change my API key to invalid API key, for instance, I'm going to get a 401, meaning that I'm not authorized to consume the API. So either ways, if I don't send a API key, or if I send a wrong API key, I'm going to get a 401. So that's the API key security policy to control the exposure. Later on, if you can try it yourself, you can implement another security policy for your routes, this time integrating Cognito. So back there, later on, you got instructions to instantiate a Cognito infrastructure and then apply a different plugins, not the API key plugin, but the OpenID Connect plugin. And then this time, instead of base your authentication mechanism on API keys, will be the case to use the OpenID Connect standard. So one last exercise I like to run before we go is the rate limiting using Redis, as I said before. So for instance, let's create another. That's another Ingress is going to face another. Let's use the same Ingress we used before. So yeah, let's create this rate limiting. Yeah, hold on a second. Let's use these Ingress instead. Full Redis. Yeah. Okay, good. So here's my new Ingress declaration. Instead of this one, I'm going to apply a new one, new version. So I got a new Ingress this time. It's full Redis path. So again, if I consume it, full Redis, I'm okay to consume it. But this time I want to control the exposure again with the rate limiting policy. So here's the rate limiting policy. And then again, if I defining a 5-minute rate limiting policy times per minute rate limiting policy. And again, if you try to consume it, eventually we're going to get, as you can see here, the specific headers related to the rate limiting policy. And then eventually we're going to get a 429 as expected. There you go, 429 error code, meaning that we have reached the rate limiting policy. But there's a tricky configuration here. So let's say this time, if we have more than one replica for our data plane. So let's, as I said before, we got only one data plane instance running. So let's deploy two more replicas for the data plane. And then Again, as you can see right now, we got 3 pods for my data plane. I'm doing it manually. Of course, for real world scenarios, you're going to use HPA in order to do exactly the same thing in an automatic way. So you don't have to manually define how many replicas you want to have this time. So yeah, so let's say we got 3 pods for our data plane. And what happens if we start a loop consuming this exactly the same route? You're going to see a very strange, interesting behavior. So we're going to reach 429, but then eventually you're going to get 200 again. So kind of a different behavior. Let's sleep a little bit to get a slower response. So 200, and then eventually you're going to get a 429 because you're going to reach the rate limiting policy. But then again, we're going to get 200 again. So kind of strange behavior of your API consumption. So as you can see here, the counters, they're not exactly going straight. So kind of, 200s and 429s, getting 200s and 429s at the same time. That's a kind of strange behavior. And why is that? Because each one of these pods, data plane pods, they are dealing with the specific counters for the rate limiting. That's the reason why. So the pod number 1 is at its own counter, number 2 is on counter, and so on and so forth. That's the kind of behavior it's not acceptable for a real world scenario. So that would be the case to externalize these counters to external Redis infrastructure. And then the Redis will be responsible for storing the same counter for all pods. So all the pods will rely on Redis to store the counters, therefore to manage the rate limiting policy. So in order to do it, let's keep the loop in here, just showing this strange behavior. And then again, let's deploy Redis first of all. Again, we got new pods in our deployment. Redis, the Redis pod is here. And now we got to change our policy a little bit, our rate limiting policy a little bit, because this time we're going to use exactly the same policy 5 times a minute, but this time the policy will be relying on the Redis infrastructure. That's the main difference over here. The policy, and then I'm referring to the Kubernetes service for Redis. That's the Redis Kubernetes service. So if I change the policy, exactly the same policy, you are supposed to see the right behavior. So 429, just waiting for another minute now, and then 200, and then as you can see here, the counters fall in the right sequence. So 429, no more 200, because the pods, they are going to rely on the external Redis. So again, the data planes, all data planes right now, they are relying on Redis in order to control the rate limiting. And then of course, if waiting for another minute, we will be able to consume the route again, meaning that we're going to get 200. Then eventually you're going to get a rate limiting policy to 429, and the process goes on and on and on. Hope that makes sense. So I think that, we're running out of time right now. So I think that will be it for today's workshop. So any questions from the audience?
So at this point in time, I'm not seeing any new questions that have come in. So real quick, I can give away some gift cards and do a little bit of housekeeping and give our audience a final moment to send in anything they might have.
Yeah.
So I'll take this opportunity to remind everyone that this session was recorded. So if you missed any of it, you'd like to rewatch, follow along again, or just listen to it while you're running on a treadmill, the on-demand recording will be made available shortly. You should receive an email with a link to access the recording on demand, and you'll also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So our 4 $25 Amazon gift card winners are Kathy Wan W, Wayne L, Sigrid D, and Breeza D. So to the 4 of you, congratulations. Keep an eye on your inbox to claim this gift card, and if you don't receive an email, just check your spam folder. Notice any new questions coming in, guys?
I don't see any new questions coming in. So yeah, I'd like to again to thank you so very much for joining us for this workshop. We're going to as a matter of fact, we are right now updating the workshop landing page with the new Ingress declarations. So please, when you have time, when you have a chance, please check it out. We are updating for the new Kubernetes version, the Ingress controller declarations back there. And yeah, that will be our pleasure to move on with these fascinating discussions, including Kubernetes, Cong gateway, hybrid deployments, and so on and so on. Thanks so very much.
All right. Well, Deborah, Claudio, we really appreciate you taking the time to be with us. And Deborah, did you have anything you wanted to say before we close out? I didn't mean to cut you off.
Sorry, I was just trying to unmute here. No, I don't have, the only thing I want to remind everybody that joined us today is that the temporary AWS accounts will be valid until the end of the day today. So you still have some time to, use those accounts and go through the instructions. And also the Cong license will be available for 30 days. So you can use that at any time with your own AWS account after today. But we also would love to connect with you all here. If you have any specific questions, or if you want to do some kind of workshop specific to your organization, AWS does hold events like immersion days. And these are workshops that we run with specific groups. And it's tailored to your organization. So we can definitely work and create something like that for you if this is something that is interesting for you. So feel free to connect with either Cong or AWS. And also, if you, I know we already addressed some of the issues that we're having on the workshop today, but if you notice any other issues while you're going through the steps, you can open a GitHub issue on the, if you notice at the very end of the instructions on the next steps, there will be a link for you there where you can create an issue request there. And then someone from Cong or AWS will get back with you on that. And then the very last request that I have is just once you are done with working through this workshop, you can go through that step 7 on the instructions to clean up the environment. Just to be mindful in terms of using those resources. So that's pretty much all I had to finish up the session today. So I just want to thank you all for joining, and I hope you learned something from us with Cong on AWS. And I'm looking forward to hear from you all if you have any questions. Thank you.
Thank you.
Great. Well, thank you, Deborah, and thank you, Claudio. We really appreciate the time that goes into putting these workshops together and the expertise that goes into actually pulling them off. So thank you both so much for your time and your expertise. I would like to thank AWS and Cong for sponsoring today's workshop. And my final thanks goes to you, our audience. Thank you for hanging in with us for an extra 20 minutes today. We hope to see you at a future upcoming Techstrong Learning webinar, and have a great rest of your day. Again, thank you, everyone.
Thank you.
Bye. Thank you.